Hi, my name is Kellen Billadu, and today I'll be covering a video of Christoph Hamel's trampoline tricks for the fifth and final lab in Physics 2211. The purpose of this lab is to see how Hamel's jump and bounce exhibit energy concepts in the real world. Some important equations to know are the equations for energies like potential and kinetic. You should also know how to calculate the total energy as well as changes in energy over time. After watching the video, I will give my hypothesis. We can see in this portion of the video that Hamel drops and springs back up to a similar height. So what's going on here, and what does this have to do with the conservation of energy principle? We aren't given the exact height that Hamel is dropping from, and the perspective makes it difficult to do pixel measurements, so we can't use Tracker to model Hamel's movement here. Fortunately, we don't need to. Understanding that all of Hamel's initial energy and final energy are potential, we can compare them to find delta E. Hamel ends up lower on the pole than in the beginning, telling us that the system lost energy due to this interaction. Now, it's important to define the system. The system in this example is Hamel, of course, the pole, the air he falls through, and the trampoline. From the get-go, we can hypothesize that Hamel will lose energy through air resistance, friction, and imperfect interactions with the trampoline. To make this model visually simpler, we can model it as a bouncy ball springing on the floor. Here is a video that displays this model well. I meant to use Tracker, but the software wasn't working. Instead, I went frame by frame through the video to gather data on the position versus time. The video was framed at 600 frames per second, but then lowered to 30 frames per second. Using that information, we can divide by 600 to get the amount of seconds that have passed during the video. Then we can take the times of the peaks and troughs of the bounce, as well as the ball's mass to calculate our values. The data fields are time, height, potential energy, kinetic energy, leaked energy, and total energy. Here are the graphs of the position and energy over time. You can see that the peak is lower after each consecutive bounce. The energy graph shows the leaked energy increasing over time after each bounce. And you can also see that the kinetic energy and potential energy fluctuate over time, and the total energy is the sum of all of those energies. The leaked energy is most likely due to heat created on each bounce. There also might be a bit of energy lost due to air resistance. Similarly, returning to Hamel and his bouncing, Hamel lost energy due to heat generated from contacting the trampoline, from touching the pole, and moving through the air. Hamel might also have contacted the trampoline imperfectly so as to not gain as much energy as possible. To answer the initial question, is Hamel violating the conservation of energy principle? No, his potential and kinetic energies are being leaked into the surroundings and other forms of energy like thermal energy.